Alright, today's video is solving systems of rates. This is going to be a fun lesson, so let's go ahead and get into it. This is Standard Mastery 8. Before we get into the actual example, we just have to draw the parallels between the formula that is being used in this problem and the formula that we know. So it's distance equals the speed you're going times the time it takes you to go that distance, which is the same exact thing as distance is y, the rate is slope, and the time is x. So let's go ahead and get in the problem. A train leaves the station at 1 p.m. and travels at an average rate of 20 miles per hour.
Boom, got the rate.
Got the rate. 3 hours later,
Sounds like time to me.
a second train leaves the station to catch up to the first one. If train 2 travels at an average rate of 50 miles an hour,
Boom, second rate.
then how long will it take before it catches up to train 1? So we're trying to figure out if train 1 leaves and later on train 2 leaves, traveling at a much faster speed, how long will it take for it to catch the first train?
How long? Sounds like Chinese, but it's really talking about time.
It is talking about time. So we don't know time because how long is referring to time. So we're going to go ahead and figure out what our y is, what our slope is, and what our x is for both train 1, we'll just say T1, and for T2.
Now, y obviously represents distance. We don't know any distances. It doesn't tell us any distances, so we're just going to leave y as y. For m, that's our rate. We already found two rates. We found our rate for our first equation, which is 20 miles per hour. That's our rate. That's our slope. And we found our rate for the second equation, 50 miles per hour. That's our rate. That's our slope. X is time. We don't know a lot about time, but we know a little bit about time. We know that train 1 travels for some amount of time. Don't know much, that's just x. We know that train 2 travels for the same amount of time, except it's 3 hours later, which means it's 3 hours less. So same amount of time, which we'll call x, minus 3 hours. Boom shakalaka, we are ready to make some equations. Woo! This is fun! First equation, y equals 20x. Second equation, y equals 50, open parentheses, x minus 3. Believe it or not, those parentheses are extremely important because it's traveling at 50 miles per hour. So if it leaves 3 hours later, it is 150 miles behind. That's 50 miles for each of those hours. As we distribute the 50, you will see the magic happen.
Actually, we're not going to distribute the 50 because we don't have to, because the calculator has parentheses. Whoa.
Little glitch. There's the calculator.
Okay, here's the calculator, and let's just move that so we can see both equations. So we're going to move it right here.
Man, glitches are fun.
So we're going to go to the graphing feature, right? And then before I type in these two equations, I'm going to make this really easy on myself, and I'm going to set the window up first. If you set the window up first, then it's going to make finding the point of intersection really easy. So the min x value, well, x is time. You can't go negative time, so we'll just make that 0. The max x value, well, it looks like we've got 3 hours, so I'm going to assume our time's going to be within like maybe 15 hours. I don't know. I'm not going to make it too much. We'll use a scale of 1. For y, the min distance, well, we know that you can't go negative distance, so let's just make that 0. And then the max distance, he said something about 150 earlier, so let's just play it safe and say, I don't know, 600. And we're going to make the scale here, 50? 50 is good for me. So now we can go and type in our two equations. So the first equation for train 1, we had y equals 20, and our x variable is over here. And for the second equation, we had y equals 50, and then we got these parentheses, so we don't have to distribute. We'll just let the calculator do the hard work for us.
Boom. No distribution. That is fun.
So I'm going to move this up now that we can see. So I'm going to resize this down. So you can see very clearly, because I set the window before I entered in the equations, identifying that point of intersection came a lot easier than it has in the past. It's
but it
right
is
here.
Yeah, it is kind of down in the corner. We could probably hit zoom in a couple times.
Zoom in a little bit.
That's out.
That's out.
That was fun, though. Let's zoom in. More fun. More fun. Little more. Little more. Little more. Little more. Little more. Let's go a little more. Whoa, that was crazy. Okay, little less. Little less. What are you doing? Okay, this definitely looks like it's pretty close to 5. I mean, that looks pretty close to 5. But if I'm not sure, I'm just going to check the table.
Check the table.
Check the table. What do I want my initial x value to be? Not -5 because there's no negative time. I want it to be +5. I'll type a 5 in. I will hit apply. It starts me at 5, 5, 100, 100. These matching y values, y1 and y2 are equal. That means I have found my solution. So 5 is x, 100 is y for both lines. That's the solution. So I know that x is 5 hours. And I know that y is 100 miles. Now we get to the really fun part. We get to reread the question to figure out exactly what they're asking us again. Like, what are they asking us? If train 2 travels, I'm starting halfway through because it's more fun. If train 2 travels at an average rate of 50 miles an hour, then how long will it take before it catches up to train 1? So which train are we talking about? We are obviously talking about train 2. Totally talking about train 2's time, right? How long is train 2 traveling before it catches train 1? How long is train 2 traveling? How long train 2? How long train 2? Which of these equations represents train 2? Obviously this one. What is the time for train 2? Well, it's x minus 3. Why did I write 5 minus 3? Because 5 is our x. 5 is our x. We know that over here. It's underlined. 5 is our x. Here it is right here. X is 5. So 5 minus 3, that means x equals 5 minus 3 is 3.
Don't take any chances, man. Use the calculator.
This is slightly awkward. 5 minus 3 is 2. Maybe that's an omen. 5 minus 3. Okay. 5 minus 3 is definitely 2. We all knew that. I just wrote 3 because I got confused.
No, he didn't.
Don't get confused. Use the calculator to check all your work. It's easy. It's easy. Just pull it up, type it in. You got tons of time. Use the calculator. So let me just correct my error. X is actually 2. 5 minus 3, definitely 2. So if I want to answer this question, how long will it take before it catches train 1? It takes 2 hours. How do I know it takes 2 hours? Because train 1 traveled for 5 hours. That's the time, XX. 5 hours. And train 2 traveled for 3 hours less. I hate that announcement machine. Can you hear that? I hate it. I hate it! We're working right now. We don't need people talking over the intercom. We don't need it. But it's fun. It's fun to hear it interrupt our videos. It's my favorite thing in the world! Besides teaching students, obviously. Just to reiterate now that the announcement's over, our answer is 2. How long did it take train 2 to catch up? It took them 2 hours.